All right, today we're going to be taking a closer look at our line of best fit worksheet here. A lot of this, if you recognize, is just going to be some basic data that you're looking at and you're trying to draw some conclusions from that information. So kind of predicting what the next piece would be. At least that's how we've been looking at it recently. All right, so this first one here, it says the scatter plot shows the number of CDs, what are CDs, in millions that were sold from 1999 to 2005. If the trend continued, about how many CDs were sold in 2006? So if you notice, CD were actually declining like crazy. Because around this time, as some of you were little kids, that's when the digital age was starting to boom. So again, less physical CDs and more digital information there. All right, so if you notice, this would actually be 06 on the next one here. And you are talking about in the form of millions. So again, you can go ahead and take your line of best fit. So take your straight edge. And you're going to go ahead and make a line. Now remember, the line of best fit sometimes does not actually go through every single point. So that's why we're definitely going to be doing it with pencil and eraser in case you need to adjust it. So if you can kind of make something like this might be a good representation, where it goes through maybe some dots, maybe it's even balanced on both sides, something around there. This might be an okay description of your line of best fit. So again, the benefit of doing this digitally here is it does allow me to adjust it accordingly. Now again, if I could fit everything in the actual line with the dots, then it'd be, of course, a linear equation. But this one is, again, a trend, trying to figure out the trend is obviously a negative, it's declining. But what is it going to be here? So if it were to continue like this, it appears that in 06, that my point would be maybe around here, which would be in the 650 million range. But again, that's not guaranteed, but you're just kind of making a prediction here based off your line of best fit. So again, if you notice here, 99 up to 2000 actually went up, then it declined, then it declined, and then it went back up. So again, it's just kind of finding a trend of what's going on. Overall trend is declining, though. It's negative correlation there. All right, let's try the next one. The table below shows the predicted annual cost for a middle-income family to raise a child from birth until adulthood. Draw a scatter plot and describe what relationship exists within the data. So go ahead and see if you can go ahead and plot that information there for me. So again, you got the age and then the annual cost. So let me do that with you. You should be caught up. This is more just a traditional scatter plot instead of line of best fit. Okay, so age of 3, and this is cost in 1,000, so that's almost 11,000. So 3 is just a little bit below that. So let me zoom in. 6 is 11,700, so it's almost 12,000. So a little bit, maybe right around there. 9 is 12,600. Not quite 13,000, a little bit above the middle, maybe right about there. 12 is exactly 15,000, so that's nice. Ooh, I wonder why there's a big spike there going from 9 all the way up to 12. Preteens. And then 15 up to 16,700. Maybe right around there. All right, so we have our scatter plot, and it wants you to describe the relationship that exists within this data here. So again, go ahead and talk with your partner about that relationship there. You can make a sentence about the age of the child and the annual cost of raising that child. Born in 2003, that should be right around your age, I think. Some of you are born maybe 02. So again, we have our words to talk about that correlation, that positive, negative correlation. You can just do generic terms about the age and the cost. So again, you should be sharing with your partner. Give you about 20 more seconds about this relationship. All right, so what you should have discussed with your partner is, first of all, is there a relationship at all? Because sometimes when we're talking about scatter plots, sometimes there's no relationship. But it appears with this one here, again, 0, you know what, if the baby's 0, you've already spent a lot of money, so maybe it's around here. Who knows? But if you notice, based off this idea with the whole line of best fit, like we've been talking about, it is a positive relationship. It is increasing, so it's positive in that sense. And it is kind of linear. It's not exactly linear, but it is kind of linear that the grouping is really close to this line. We don't necessarily have any outliers or gaps or anything like that because we don't have as much data as we'd like. But it looks okay. Positive linear relationship, I think, would be good. A simple sentence that you could have written with your partner is, of course, as the child gets older, the cost increases. Because again, notice how more money's being spent on the child because obviously they're alive longer, they got to eat more than the previous year, they need new clothes, activities, school, all of that stuff. Beautiful. All right, look at the next one. Ooh, make a scatter plot of the data in the table. Draw a line of best fit. What is the equation of the line of best fit? Ooh, this is a good one. All right, I'll give you a little bit of time with your partner to go ahead and sketch this. Again, all you have to do is plot your points in the correct location as I get a small drink. Ah, that was nice. All right, so let's plot our points. That's what you should have started with. Again, -2, 2, -2, 2. -2, 3, -2, 3. -1, 2. 0, 1. 1, 0. 1, 1. 1, -1. 2, -1. 2, -2. And then 3, -2. All right, so I have made a scatter plot, part 1. Draw a line of best fit. So remember, you're trying to make a line with your straight edge that will represent what you see here. So obviously it is negative, so that's that negative relationship. So, for example, if you draw it like this, yeah, that's negative, but obviously it's not in the correct location because you're trying to make it where you have your points on essentially both sides. So, for example, like this, that still probably wouldn't be good enough because you have more on one side. So maybe something, let's see, I could adjust it a little bit. Maybe something like that. Maybe something like this. Ooh, that one looks pretty good right there. Now, the thing about line of best fit is if you were to check it, it should come really close to what you have for your X and Y. So if you notice, what I have here is 1 point on the upper side, but 3 points on the lower side. So if you wanted to get even better, you might have it more at an angle maybe, but then it kind of opens that up. Maybe something like that, but I actually really like this one here. Let me zoom in so you guys can see a little bit better. So again, I have drawn a line of best fit. Now, one thing that we like to talk about is it's maybe the line of the closest best fit, which means we can't get it exact, and that's what a calculator is for, or a website, or any type of computerized line of best fit. Again, we're getting the line that's the closest possible. All right, so if you remember when we did our graphing information, we need a slope and a y-intercept. Now, we obviously know the slope is negative because it is going downhill. We need rise over run, and we need our y-intercept. So the way that we did it previously is we look for the y-intercept first. Y-intercept again is here, and that's at 1. And then downhill, for our slope, we need another point here. So according to this, it'd be down 1, right 1, down 1, right 1. So that gives me a slope of -1 over 1. And if we put it together, that's going to be y is equal to -1 over 1, or just -1x, and then a plus 1 there. So again, you could check it to see if it would come really close, but for example, this one here, that'd be a little bit off. Again, that is -2, +2. So it means if I put in my -2, -1 times -2 is +2, 2 plus 1 is 3, and that's not at 3, that's at +2. But all the other ones, if I were to check, it would be actually really good there. So for example, this point here, that's at x is -1, so -1 times -1 is 1, plus another 1, 1 plus 1 is definitely 2. So again, line of best fit is just trying to get as close as possible. Ooh, this one should be very interesting for some of you. The table at the right gives the number of hours spent studying. That means you actually spend some time looking at your notes, doing some extra problems, if you guys didn't remember or even know what studying meant. That's what it means. For a science exam and the final exam grade, draw a scatter plot of the data and draw in the line of best fit. What is the equation for the line of best fit? Exactly what we just did previously. Now you're going to do the extension. Predict the grade for a student who studied for 6 hours. Could this line go on forever? Why or why not? So I'm going to actually ask you guys to do this one on your own. If you notice here, you've got your x and your y axis. So let me go ahead and maybe make it just a little bit darker for you guys. So down here. Now, if you notice, it might be wise if you say the study hours is the x. So I'm going to go ahead and write that in, study hours. And then the y would actually be the grade. Ooh, writing sideways. And if you notice, the lowest grade that you see here is a 60, so that means maybe this part here would be a 60. And then you can keep going, increasing maybe by 5s or something like that to try and get up to, obviously, your 100, but 92 is the current highest grade. All right, so go ahead and put your extra numbers there. Maybe the numbers down here on the bottom again. You've got 0 hours studied, 1, 2, 3, and so on. You're going to plot your points. Then you're going to draw a line of best fit, just like we did on our previous problem here. And again, you're going to try and get as close as possible. What is the equation of the line? So just like I did here, find your m and your b to make your equation. Predict the grade for a student who studied 6 hours. So eventually, if you kept looking at the x-axis, you would see 6 hours, and you would see your grade. Now, obviously, the connection is the more you study, the higher grade you're going to have, and so on. Could this line go on forever? Why or why not? That's your critical thinking component. Just need a simple sentence there to go ahead and do that. All right, so we'll come back to that, give you some time when we're done with the video that you can work on number 4. All right, number 5, baseball. The scatter plot shows the average price of a Major League Baseball ticket from 1997 to 2006. Use the points to write the slope-intercept form of equation for the line of fit shown in the scatter plot. Again, line of best fit or line of kind of close fit, and so on. Use the equation to tell the price of a ticket in 2009. Is this extrapolation or interpolation? So again, we can look at those words again in just a moment, but once you have it, you can predict what the price would be for 2009. So again, this would be 07, and then eventually 08, 09, and so on. Let me shrink it a bit. All right, so let's see here. Use the points 2001 and 2002 to write the slope-intercept form equation for the line of fit shown in the scatter plot. So again, we need M and B. It's asking us to use these 2 points here to help us find the actual slope. So if you notice, it's really just the change of x over the change of y, and that's what we've done before. y2 minus y1 over x2 minus x1. So again, this is x1, y1, and x2, y2. All right, so I'll give you guys a moment to go ahead and plug those numbers in like we've done before to try and find the slope. Remember, plug your numbers in, please. Almost ready. All right, so your numbers should be plugged in. So let's see. The y's at the top would be 1875 and 1760. And then the x's, again, would be 2002, 2001, but really it's just something over 1. So, doing your basic subtraction, we've got 1875, subtract 1760, and you get a $1.15 increase every year. That's essentially saying what's happening. So if you keep that in mind, you could use that as well to help you on this idea for the equation to tell you the ticket price of 2009. So again, in order to actually make a true equation, I kind of need a starting point here. So let's see, it says if I look at my graph, 0 is about 12 something. So that may be $12 and maybe let's say 25 cents or something like that. All right, so our equation then would be y is equal to a $1.15 increase every year. So that's the x. And then it started off at $12.25 or so. Now, in order to actually find the ticket price for 2009, it's not like I'm going to plug in 2009 because that's going to come out for an outrageous amount for a baseball ticket. So what you need to do here is actually talk about the years and so on of what actually took place. So maybe look at this here as, okay, if that's year 0, then maybe this is year 1, year 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 08 would be 12, and 09 would be 13. So that's a way to possibly do it. Now, this may not come out fully accurate, but again, it's called the line of best fit. So in other words, it's kind of close. So if I were to do it this way, y is equal to $1.15 times the 13, because that's year 13, plus 12.25. So you could go ahead and figure out what that's going to be using a basic calculator or actually your information, just side multiplication and things like that. So looking up here again on extrapolation, the website, or I guess just Google says, the action of estimating or concluding something by assuming that existing trends will continue or a current method will remain applicable. So in other words, can we assume that it keeps increasing based off the line of best fit? I believe that could be it. Let's look up interpolation. Let's see, Google says, interpolation, the insertion of something of a different nature into something else, a remark interjected in a conversation. Let's see it, math. Interpolation is an estimation of a value within two known values in a sequence of values. That doesn't really help us out. Linear interpolation. Linear interpolation is a method of curve fitting using linear polynomials to construct new data points within the range of a discrete set of known data points. I think I like the other one, the extrapolation. So in other words, I'm just kind of assuming that the trend is concluding or continuing, and that's why I was able to come up with the years there. Now, you may want to keep that in mind. Hint, hint, wink, wink. All right, let's talk a little bit about 6 and 7 that you can complete on your own. The table shows the number of cases of foodborne botulism in the United States for the years 2001 to 2005. Draw a scatter plot and determine what relationship, if any, exists in the data. So we've talked about that before. Plot your points. Is it a positive relationship, linear, of course, negative relationship, or is there no relationship going on? All right, part B, draw a line of fit for the scatter plot and write the slope-intercept form of an equation for the line of fit. So again, we've already done this many times, so you guys can go ahead and do that. Plot your points. Is there a relationship? Draw a line. What's that equation? M is our slope. Remember, rise over run. B is our starting point. Can you figure that out? Now remember, when you make your line, you're going to try and either have it on as many points as possible or kind of in between to help you out. All right, number 7. Last one. The table shows the average and maximum longevity of various animals in captivity. Draw a scatter plot and determine what relationship, if any, exists in the data. You guys can do that. Check. Draw a line of fit for the scatter plot and write the slope-intercept form of an equation for the line of fit. Again, remember that's M is equal to and B is equal to. So if it's uphill, it's positive. Downhill, it's negative. Part C. Predict the maximum longevity for an animal with an average longevity of 33 years. Is this an example of extrapolation or interpolation? Again, you can look those up or think about what I just told you. So 33 is going to be somewhere in here. So you guys can figure out what that's going to be. Now, if you notice, 33 is within the data range that you have. So I think that's more of the interpolation that I have because that's within the data points. The extrapolation was more along the lines of, okay, my data has ended. What can I predict outside of my data range? All right, so again, you're going to plot your points. You're going to make a line, going to try and make a line of best fit from that, and then try and guess or estimate, predict what's the maximum animal longevity of years for the 33. All right, very good, very good. What you're going to do now is work with your partner to complete those problems that we did not complete together. And then when you're done, you're going to go ahead and read quietly or work on other homework.